Have you ever been on a sailboat? It's really amazing. Did you ever think about how we describe the things that are around us? Like this beautiful boat I'm on. It's hard and strong. We know it's solid. And what about the blue-green water rolling in the ocean around me? It's water, and we know that it's a liquid. And the open blue sky above me. We know that it's full of the air we breathe. That's called a gas. Yes, I'd say this is the perfect place to start a journey to learn about solids, liquids, and gases. So let's go. The first thing we need to know is that all things are made up of matter. Matter is anything that takes up space. And all matter is made of tiny particles called atoms. Atoms are much smaller than a grain of sand. In fact, one tiny grain of sand is actually made of millions of atoms. And the thing to remember about these particles is that they can move. Today we're going to talk about solids, liquids, and gases, the three forms in which we see and touch matter every day. Solids, liquids, and gases. What makes them different is how all the tiny particles in them are moving. When something is solid, like a bowling ball, this bowling alley, a boat, even this burger, the particles inside it are packed tightly together. There's not much room for them to move around because they're packed so tightly. This makes the object look and feel a certain way. It has a definite shape, like a baseball, a plastic cup, or a rocking chair. They're all solids. If you could actually see all those tightly packed atoms, it might look something like this, very crowded. This block of ice is solid. It keeps its shape so well that this sculpture can chip away and slowly create a piece of art. The first thing we know about liquids is, of course, they're wet. And while solids keep their shape, liquids do not. Liquids can be just about any shape. And of course, you can't spill a bowling ball or a computer or a car, but you can spill a liquid. This water in these buckets is splashing around quite a bit. The buckets are solid. They keep their shapes. But the liquid water changes shape to fit the buckets. That's what liquids do. They change shape to fit whatever is around them. Here's a sweeter example. To make a cool drink like lemonade, you start with fresh water. As you pour the water into the pitcher, it changes shape to fit the pitcher. Then, as you pour the lemonade from the pitcher into a glass, the liquid changes shape again to fit the shape of the glass. Here's something to think about. What shape does lemonade have once you drink it? I guess that depends on the shape of your stomach. Some liquids pour more slowly than others, like syrup. That's because the particles in syrup are closer together and moving slower than they are in water. That makes the liquid thicker and it moves more slowly than, say, lemonade. Motor oil is a thick liquid that's used in car engines and all kinds of machines to help make them run smoother and quieter. It works well because it's thick, but also because it's a liquid. Remember, when poured in, the oil takes the shape of the inside of the engine. So, solids keep their shapes and liquids change their shape. The next phase of matter changes shape too, but you can't always see it. It's gas. Gases are all around us. The air we breathe is really a mixture of gases. This giant balloon is being filled with gas right now. As it fills up, the balloon traps the air inside. That's the thing to remember about a gas. It spreads out as far as it can and fills up the space it's in. Take this balloon. It's being pumped full of air. If the balloon walls weren't here, the air inside would spread out all over and just become part of the sky. I found a couple of neat drawings to help you picture the difference between solids, liquids, and gases. If you put an ice cube in a jar, it just sits on the bottom of the jar. Because it's a solid, it keeps its shape. If you put a liquid in the jar, it fills up the bottom and takes the shape of the jar. That's a liquid. Now, if you filled the jar with a gas, it would spread out to fill the entire jar. And that's an easy way to remember the difference between these three forms of matter. So let's review what we've learned so far. First, we know that all matter is made up of tiny particles called atoms, and that these particles can move. In some things, the particles are packed tightly together and are not able to move around much. These are solids, and they keep their shapes. In other substances, the particles are farther apart and can move around more freely. These are liquids, and they can change shape very easily. Liquids take the shape of whatever container they are in. And in some substances, the particles are able to move very fast and spread far apart from each other. These are gases, and they spread out to fill the entire space they are in. Knowing about solids, liquids, and gases is only part of the story. Now we're going to find out how matter changes from one form to another. The key to it all is energy. You can think of energy as movement or the ability to move. If a runner is moving fast, we say he has a lot of energy. But if he gets tired and can't move so fast anymore, we say he's running out of energy. A speeding motorcycle is using a great deal of energy. Much more than a motorcycle standing perfectly still. For anything to move, it needs energy. And that includes atoms. The more energy matter has, the more the particles in the matter are moving. This is how matter is able to change from one form into another. Like this ice cream. Here, it's a solid. The particles in it are packed together, not moving much, and it keeps its shape. But if I start to heat it up, the particles in the solid ice cream start to move faster and spread out. That's because heat is energy. As the energy from the heat makes the particles move faster and spread out farther, the ice cream starts to lose its shape, and it turns into a liquid. It's melting. The temperature at which a solid turns into a liquid is called the melting point. Remember that huge block of ice we saw earlier? Well, the same thing happens here, but without a hairdryer. The air around the ice is warmer than the ice itself. Heat energy from the air starts to make the particles in the ice move faster, and some of the ice reaches the melting point. The solid ice melts into liquid water. At this ice skating rink, it's important to keep the ice solid. That's why it's always cold inside this building, because if the air was warm, the ice would melt, and instead of skating, I'd be swimming. And you probably know that melting works in reverse too. It's called freezing. When a liquid cools down so much that its particles slow down and move much more slowly, it becomes a solid. It freezes. The temperature at which a liquid turns into a solid is called the freezing point. When you put ice cream in the freezer, it's important that the temperature is colder than the freezing point of the ice cream, or you'll end up with quite a mess. Remember, both freezing and melting involve energy. Melting is what happens when solids heat up and gain energy. Freezing is what happens when liquids cool down or lose energy. So we've seen how solids can melt and liquids can freeze. But what about gases? How does matter take the form of a gas? Well, the first thing to know is that a gas usually comes from a liquid, and it happens in the same way as melting, by adding energy. As water warms up, the particles at the top start to move faster. Some of them move fast enough to break free. The liquid water turns into a gas called water vapor. When a liquid turns into a gas, it's called evaporation, and it happens on all oceans, rivers, lakes, anywhere water comes into contact with the air. When water evaporates, it usually happens pretty slowly, so we can't even see it. But do all liquids evaporate as slowly as water? Let's find out. Here's a fun experiment that will test how fast two different liquids evaporate. You'll need the following materials: water, rubbing alcohol, paper towels, a tablespoon, magic marker, scissors, a round pencil, a ruler, 2 large and 2 small plastic cups, some tape, and a few extra hands, including an adult helper. First, place your 2 large plastic cups upside down on a flat surface, a little less than a pencil's width apart. Then, lay the pencil across the cups and tape the pencil down at each end of the cup. Next, carefully balance the ruler on top of the pencil. It's a little tricky, but you can do it. Now, have your adult helper cut 2 strips of paper towel, each 20 centimeters long and 4 centimeters wide, and mark each strip. Label one for the alcohol and one for the water. Using the 2 small cups, pour 1 tablespoon of water into one cup, 1 tablespoon of alcohol into the other. Remember, water and alcohol are both clear liquids, so be careful not to mix them up. Using both marked strips, dip one into the water and the other into the alcohol until each is completely wet. Now it's time for a little teamwork. This is a bit tricky. Place the wet strips at the very ends of the ruler while keeping it balanced. And do both at the very same time. Watch the ruler closely as the alcohol and water in the paper towels evaporate. Can you predict which liquid will evaporate first? And what will happen to the ruler as the liquids in the paper towel evaporate? Finally, we see a change. The ruler has tipped over toward the end with the water. Can you explain why? Well, here's the answer. The alcohol evaporated much quicker than the water. That means that it became a gas and floated away into the air. But the water on the other paper towel did not evaporate so quickly. That changed the balance of the ruler, kind of like a seesaw. And it fell off the pencil. And it happened because alcohol turns from a liquid to a gas faster than water does. We know that water evaporates pretty slowly, so we can't usually see it. But there is a faster way to change a liquid into a gas. If I keep the pot of water over the flame on my stove, the water at the bottom gets hot very fast. This makes bubbles of water vapor that start floating to the top and popping. The water is boiling. It's turning into a gas so quickly that we can see it happening. The bubbles keep popping and the water vapor is released into the air as steam. The temperature at which this happens is called the boiling point. If I keep boiling the water, eventually it will all turn into steam and my pot will be empty. Now, one more thing about gases. We learned that a liquid can become a gas when it is heated. Well, once again, the same thing works in reverse. If a gas is cooled down enough that the gas particles slow down and crowd more tightly together, it turns into a liquid. This is called condensation. Evaporation and condensation are very important to life on Earth. Water is constantly changing from a liquid to a gas and back to a liquid again. It works like this. Water from the oceans turns to water vapor and rises up into the sky. Evaporation. Then it cools down and turns into liquid water again. Condensation. That's what clouds are. Giant clumps of water vapor high in the sky. Eventually, the water falls back to the earth as rain or snow. This process is called the water cycle, and it's the reason we have enough fresh water to survive. All matter can exist as a solid, a liquid, or a gas, but most things in our world stay in just one of these forms. A rock is pretty much always a solid. Air is almost always a gas. And pancake syrup is pretty much always a liquid. But they each have a boiling point, a melting point, and a freezing point. The thing to remember is that these temperatures are different for different kinds of things. For example, the melting point of ice is 0 degrees Celsius. That's 32 degrees Fahrenheit. That explains why water can change form very easily. But the melting point of iron is 1500 degrees Celsius, so we know iron almost always as a solid. I'm making some final notes on what we learned today. Let's review. First, we found out that anything that takes up space is called matter, and that matter is made of tiny particles called atoms that can move around. We learned about 3 different forms of matter. In solids, the particles are packed so tightly together they can barely move. This allows them to keep their shapes. The particles in liquids are able to move around faster and spread out farther. Liquids change shape easily. In fact, they take the shape of whatever container they're in. In gases, the particles move very fast and spread so far apart that they break away from each other. Gases keep spreading out to fill whatever space they're in, like the hot air balloon. Then we found out that matter can change from one form to another when energy is either added or taken away. When water loses energy, it cools down. The particles stop moving and it turns into a solid, ice. As water warms up, adding energy, the particles move faster and spread out farther. This is how a liquid becomes a gas. One way is evaporation, when it happens slowly at the surface. And the other is boiling, when it happens much more quickly. When a gas cools down and turns into a liquid, it's called condensation. And finally, we learned that all matter can change forms, but it happens at different temperatures depending on the kind of matter. Well, it's time to wrap up for today. We learned a lot about solids, liquids, and gases. But there's one more thing I wanted you to know. Things in our world are constantly changing. People start out small, and then one day they're all grown up. But they're still people. A potter can throw a chunk of clay down and then tug on it, press on it, and stretch it. But it's still clay. When I boiled water, it turned into steam, but it was still made of water molecules, only in another form. All these changes we've seen do not change the matter we started out with, only the properties of that matter. And that's what I want you to remember, that matter can change form from a solid to a liquid to a gas and still be the same matter. Gotta go. Bye.